Hello, I'm Matthew, and today we'll learn how to factor special cases of quadratic equations. Here's our first question. Factor x squared plus 6x plus 9. This doesn't look like a special case at all, but at the end you'll see why. We can still solve this by using our regular method, which I'll demonstrate right now, but also at the end I'll show you how to solve these questions much faster. Using a regular method involves finding two numbers whose product is equal to positive 9 and their sum is positive 6. So I'm going to draw a chart to keep track of our products and sums. So what are the two terms that when you multiply that they become 9? Well, first we can try 1 and 9, but when you add them, they are equal to 10. What are the other two numbers that we can try? Well, 3 times 3 is equal to 9, and 3 plus 3 is equal to 6. Oh, that means that when you factor x squared plus 6x plus 9, that is equal to x plus 3 times x plus 3. Where did we get the 3's from? Well, first 3 we got it from here, the second 3 we got it from here. If you have no idea what we're doing, please check out my other video about factoring. That video explains this regular method a little more thoroughly. But anyhow, this equation can be rewritten as x plus 3 squared. And this is why this is called a special case of perfect squares. And here's a pattern. The last term is the square of the last term inside the bracket, and this positive 6 is times 2 of term over here, right? 9 is 3 squared and 6 is 2 times 3. So for the perfect squares, instead of finding two numbers whose product is equal to this and whose sum is equal to that, we're finding one number whose square is our last term and twice of that number is this number in the middle. Let's practice more by solving the next question. We have x squared minus 12x plus 36. First, recognize that 36 is square of 6. And after, recognize that we have negative 12. 12 is 2 times 6, but it is negative. Okay, so we need to think a little differently. And this is what we do. 36 is actually not just a square of 6, but square of negative 6 as well. And negative 12 is 2 times the negative 6. That means when you factor x squared minus 12x plus 36, it is x minus 6 squared. And that's how you do it. By finding one number whose square is that, but when you multiply it by 2, it becomes that. Let's try a little more complicated question. Factor x squared plus 14xy plus 49y squared. Okay, this looks a little scary because it has more than one variable, but it's actually quite similar as what we did before. First, 49 is 7 squared and y squared is just y squared. And this can be rewritten as square of 7y. And you can also see that we have 14xy, but just like before, we're not going to consider x, but only consider 14y for now. And you can see that 14y is twice of 7y. So the one term that we're looking for was 7y, and that means that when you factor x squared plus 14xy plus 49y squared, it is x plus 7y squared. And that's how you solve the special cases of the perfect squares. Next special case that we're going to solve is called the difference of squares, because this special case only has two terms, but they are both square of something. And because of the negative sign in the middle, they are called the difference of squares. I'm going to solve this by using our regular method, but first I need to rewrite this equation as x squared plus 0x minus 49. I know that we didn't have 0x in the original equation, but since 0x is same as 0, we can put it there. And now we can use our regular method of finding two terms whose product is negative 49, but whose sum is 0. So let's try. We want the product of the two numbers to be negative 49, but their sum to be 0. Well, if their sum is equal to 0, that means that the two terms are the same numbers but having different signs. For example, 7 and negative 7. When you multiply them, they become negative 49. But when you add them, they're equal to 0. That means our original equation can be factored into x plus 7 times x minus 7. We got our positive 7 from here, and we had the negative 7 from here. And this is how you factor the special case of the difference of squares. Find a number or a term that this is the square of, and you just have to have plus and minus of that number in each bracket. For example, if you had x squared minus 25, this can be factored into x plus 5 and x minus 5. And it's as easy as that. To make it a little more complicated, we can throw a variable in the second term, but it actually doesn't make it any more difficult because you can recognize that 81 is equal to 9 squared and y squared is same as y squared, and this can be rewritten as 9y and all of that squared. That means when you factor x squared minus 81y squared, that's equal to x plus 9y times x minus 9y. 9y was found from over here by recognizing that 81y squared was the square of 9y. And that's how you do it. I hope you found this video helpful. If you did, please hit the like button and subscribe. And feel free to leave a comment below on the next video that you would like to see. I'm Matthew, and I'll see you in the next video. Bye!